It's one of the most iconic and probably most hated images in the history of climate science. To some, it's a smoking gun for human-driven global warming. To others, it's statistical nonsense. But what exactly is the hockey stick graph, and why has it spent nearly 30 years in the crosshairs of the climate wars? Welcome to the podcast. I'm Dr. Mack, and this is the Climate Translation. If you close your eyes and imagine a standard hockey stick, you're already looking at one of the most important data sets in human history. The graph was first published in a landmark 1999 paper by Michael Mann and his colleagues. It was designed to show how the temperature of the Northern Hemisphere has fluctuated over the last 1,000 years. But why a hockey stick? Let's break it down into the two parts of the tool. Imagine a long wooden handle stretching horizontally across your field of vision. This represents the years 1000 to about 1800. In the graph, the line is relatively flat. It has some slight wobbles, showing some gradual warming and cooling trends over 9 centuries. It represents a world before the Industrial Revolution, where the climate shifted slowly due to natural forces. Now imagine the very end of that long handle. There's a sharp, near vertical curve pointing straight up. This is the blade of the stick, and it represents the 20th and 21st centuries. This is where the data shows a temperature spike so rapid and so steep that it looks like a total departure from the previous 1,000 years. When scientists look at this, the blade is the flashing red light. It tells us that what we are experiencing right now isn't just natural wobble like in the handle. It's a historic break in the pattern. Now, for the everyday person, the question is often, why does this one graph cause so much fighting? It's because it simplifies a very complex story into one inescapable image. If the hockey stick is right, then our current warming isn't business as usual for the planet. It's a massive, human-driven acceleration. This is why the graph has become a focal point in the climate wars. Misinformers have spent decades trying to break the stick, because if you can convince people the graph is wrong, you can convince them the current warming is just another natural cycle. But as we're going to see, it's not just one graph anymore. Since 1999, the science has only gotten more precise, adding more layers to that handle and making the blade even sharper. Now, whenever I show the hockey stick in my classroom, I have at least one student that inevitably raises their hand and asks the million-dollar question. Dr. Mack, how can you possibly know what the temperature was in the year 1200? We didn't even have thermometers, satellites, or weather apps back then. It's a great point. Reliable direct temperature measurements only go back to about 1850 in the UK and 1880 in the US. To see further back, hundreds or even thousands of years, we have to look at the natural tape recorders of Earth's history. In science, we call those proxies. A proxy is simply something in nature that records a signature of the weather at the time it was formed. Imagine a crime scene where a detective finds a footprint. The detective didn't see the person walk by, but the footprint acts as the proxy for their shoe size and their weight. We do the same thing for climate. One proxy we can use is tree rings. Certain very old trees have lived through the centuries. Just like a gardener knows that some years are better for growth than others, trees record this in their wood. Think of a tree ring like a social media status update for that year. In the good year, one that's warm and has plenty of rain, the tree is happy, it grows a lot, and it creates a wide, light-colored ring. In a bad year, maybe a cooler season or one with a massive drought, the tree struggles and grows a very thin, dark, dense ring. By counting back from the bark of today to the center, which represents the past, we can read those status updates to see exactly which years were toastier and which were cooler. If tree rings are a diary, ice cores are Earth's security camera footage. We go to places like Greenland and Antarctica and drill miles down into the ice. Think of an ice core like a layered parfait that's been sitting in the freezer for thousands of years. Every year, snow falls and gets squashed down into a new layer of ice. Trapped inside that ice are tiny, microscopic bubbles of air. When we pull that core up, those bubbles are literal time capsules. We can pop them in the lab and breathe in the air from hundreds, even thousands of years ago. We can directly measure how much carbon dioxide was in the air and use the chemistry of the water to calculate the temperature of the snow when it fell. But there are other records as well. Down at the bottom of our oceans and lakes, there's a constant snow of dust and dirt and tiny shells of microscopic creatures. Think of these sediments like the junk drawer of the planet. Everything that happens in the water eventually settles at the bottom. There are tiny organisms called foraminifera that grow shells. The chemistry of those shells changes depending on how warm the water was when they were alive. When they die, they sink and become part of the mud at the bottom. We take cores of that mud, almost like we're using a giant straw to pull out a vertical slice of the seafloor. By looking at which creatures live there and the chemical makeup of their shells, we can determine the ocean temperature from centuries ago. Now, critics often say, but the tree rings aren't perfect. They have uncertainty. And they're right. Proxy data does contain more uncertainty than modern digital thermometers, which are very precise. Everyone in science knows that. But here's the secret. You don't just use one tree or one ice core. You cross-check. If the tree rings in North America, the ice bubbles in Antarctica, and the sediment cores off the coast of Europe all show the same cooling trend in, let's say, the year 1200, confidence goes way up. It's like having 10 witnesses to a car accident. Even if one person's memory is a little fuzzy, when they all describe the same red car, you can be pretty sure there was a red car. By 1999, our confidence in these proxies was strong enough to link them to our modern thermometer readings. The result was the iconic hockey stick shape, a long, slow, slightly wobbling handle followed by a modern blade sticking straight up. Now we get into the climate wars. Because the hockey stick was such a powerful, easy-to-understand image, it became a massive target. If you were someone who didn't want to believe in human-caused warming, the blade of that stick was your biggest enemy. In 2003, two researchers, McIntyre and McKittrick, published a critique claiming the hockey stick was statistical nonsense. They argued that the math used to create the graph was so flawed that you could feed it random noise and it would still produce the same shape. You might still see that today in social media comments or on certain news segments, the claim that the hockey stick is broken or has been debunked. So as an educator, how do I explain this to a student that has seen those headlines? Well, I use a security camera analogy. Imagine a security camera catches a thief in a store. The footage is a bit grainy, and the defense attorney argues in court that the camera lens was distorted. They claim the footage is broken and shouldn't be used as evidence. In a courtroom, that might work if there was only one camera, but what if there are more cameras and they all show the same thing? In science, we don't stop at one camera. Since that first paper in 1999, the science has moved on. Independent teams of scientists, people who had nothing to do with the original study, decided to check the math. They used different statistical techniques and gathered even more data from different proxies like corals and stalagmites, which have rings like trees, and sediment boreholes. And here's the light bulb moment. They all found the same result. They did a deep dive and confirmed that while the math from the original 15th century data had some minor uncertainties, the overall blade portion, The unprecedented warming over the past few decades was absolutely real. Using sediment cores, scientists looked at temperatures deep underground in North America, in Europe, and in Africa. Even without tree rings, they found the 20th century was the warmest in 500 years. Records from the cross-sections of stalagmites and underground caverns confirm that the 20th century temperatures exceeded anything in the last half-millennium. The broken stick argument is what we call a manufactured controversy. It fixates on one 27-year-old paper while ignoring the mountain of evidence that has been built since then. Today, we have even more striking visuals, like Ed Hawkins' warming stripes. It essentially is the hockey stick for the 21st century, using 20 years of additional scientific progress to show a clear, undeniable transition from the cool blue centuries to the burning red decades of the recent past. So is the stick broken? No, it's been poked, prodded, and put under a microscope by every skeptic on the planet. And after all that, as Elton John says, it's still standing. Now, for the final piece of the puzzle, I often hear people say, so what if the graph has a blade? The handle has wobbles too. The climate has always changed. As we've discussed in previous episodes, they're right, it has. But to understand why scientists are so concerned about the hockey stick, we have to talk about acceleration. I want you to imagine you're a passenger in a car on a cross-country drive along a long highway, let's say in the Great Plains. For the first 900 miles of the trip, the car is on cruise control, doing a steady 45 miles per hour through the mostly flat terrain. That's the handle of our hockey stick. At that speed, you can relax. You can sip on your coffee, look at the scenery, read a book, or even maybe listen to this podcast on your radio. If the car hits a small bump or the speed drifts up to 48 or down to 42, you barely notice. The system is stable. But suddenly you look at the driver, and their eyes are fixed on the horizon. They slam their foot on the accelerator all the way to the floor. In a matter of seconds, the car screams from 45 miles an hour to 125. Now think about what happens inside that car. Your coffee spills everywhere. Your back is slammed into the seat. The engine starts to whine under the stress, and the tires are struggling to grip the pavement because they weren't designed for that kind of friction. Welcome to the blade. The problem isn't that the car is moving. It's the rate of change. Our entire civilization, our coastal cities, our massive wheat fields, our water systems, they were all built during that 45 mile per hour cruise control of the last 1,000 years. We simply are not designed for the 125 mile per hour acceleration we're seeing in the geologic record right now. When we look at the hockey stick, we aren't looking at warming or looking at a system that has lost its balance. We're seeing changes that normally take 1,000,000 years occur in just 200. Now, for those of you that know the graph, you probably can relate. You mentioned the hockey stick, and your skeptical cousin or your neighbor brings up a blog post they read about broken math or dishonest scientists. Your instinct might be to go to data, and while that's great for a scientist, there are better ways to bridge the gap. When someone says the data is unreliable because we didn't have thermometers in the year 1200, ask them, if you wanted to know what happened at a house fire, would you only talk to the one person that had a camera? Or would you go to the neighbor who smelled smoke, the person who saw the glow from a mile away, and the gardener who found ash on the leaves? Explain that proxies are those witnesses. We aren't just looking at one tree ring sample. We're looking at ice cores, stalagmites, corals, lake and ocean sediments. When the witnesses from all around the world all tell the same story, a long, stable handle and a sudden, sharp blade, that's not a fluke, that's a consensus. If they bring up the 2003 debunking of the original graph, use a map analogy. The first maps of North and South America were crude. Back then, the first explorers used the tools they had, sextants, and the stars to draw the coastline of a new continent. It wasn't perfect. Maybe they missed a few inlets or the shape of the bay was slightly off, but they clearly showed that massive continents existed. The first version of the hockey stick graph in 1999 was like the first hand-drawn map of the new coastline. It had some wobbly lines, but it proved something was there. Today we have the equivalent of a 4K satellite GPS image that makes the graph even sharper. The goal of these conversations isn't to make your friend a climate scientist. It's to help them realize that the controversy is often a distraction from a very simple, very visible reality. The rate of change we're seeing right now is unlike anything humans have ever dealt with. We can't explain it away, and we ignore it at our peril. We've covered a lot of ground in these first 3 episodes. We've looked at the rate of change, we've deconstructed the consensus gap, and today we looked at the hockey stick, the graph that perfectly illustrates the world we're moving into. I hope these translations help you to see the atmosphere a little more clearly. More importantly, I hope they help you build a bridge to someone else, because we can't fix a world we don't understand, and we can't understand it if we're shouting at each other. I'm Dr. Mack, and this has been the Climate Translation. If you have a question about the climate that you've been too afraid to ask, or if you have differing opinions, please let me know. I can use your viewpoints in future episodes. You can reach me at theclimatetranslation@gmail.com. I'll see you next time.